Alright, good morning everybody. So, this is going to be a new video showing how to do some of these problems from lesson 7-7, areas of circles and sectors. I'm going to do a new thing. I'm going to do the even numbered questions. If you have a book, you can find odd numbered questions in the back, and you can use that as an additional resource. So I just wanted to do the even number ones because those if you are struggling, you can use this video as a resource to help you out with those. So let's go ahead and look at number 2 here. This is from the homework packet, exercises, lesson 7-7, number 2. Okay, so we have a circle, and it wants us to find the area, and it wants us to leave it in terms of pi. So here you have a circle, we're given the diameter, that's all the way across. The area is equal to pi r squared. So that means I'm going to have to divide this diameter by 2. So go ahead and do that. So I'm going to divide this by 2. I'll just leave it in a fractional form. This way I can square both the top and the bottom and have a nice fractional answer. So this would be 100 and what is 11 squared? 121 over 4. And this will be centimeters squared. So that would be your answer. You might get a decimal if you did 5.5 squared. Look at number 4. Again, we're given another diameter. Here's our circle. It's 2/3 inches in diameter. Remember the area is pi r squared. So I'm going to need to take this and divide it in 2. 2/3 divided by 2 is 2/6 or 1/3. So I'm going to have that, and then I'll square that. 1 over 9, and I can simplify that to pi over 9 inches squared. So that'll be our area for that. Again, if you used a calculator, convert this into decimals, that's 0.66 divided by 2 is 0.33-ish, and then you square that and you should get 1/9. I'm not sure what the decimal is on that, but anyway. Number 6 is a word question. What is the difference in areas of a circular table with a diameter 6 feet and a circular table with diameter 8 feet? So we have two tables here, a 6-foot diameter and an 8-foot diameter, and I want to find out the difference between these two. Again, so this would be another subtraction problem. I'm going to get this area, and then I'll subtract this area from that answer. So I need the area of each of these. This one is going to be pi times 8 divided by 2, so 4 squared. This one's going to be pi times 6 divided by 2, so 3 squared. And it says, well, this is a word problem, so we're going to go ahead and approximate the answer here. So this would be 16 pi minus 9 pi, and I'm going to use a calculator to approximate that. So 16 times pi is 50.26, and that's from 9 times pi is 28.27. So when I subtract these from each other, I get 21.99. I'll round it up to 22 square feet. So the 8-foot table is about 22 square feet larger than the 6-foot table, which is quite a bit. Okay, go ahead and flip the page. Let's look at number 8. Find the area of each shaded sector of a circle. Leave your answer in terms of pi. So looks like the shading didn't come through on this. Hopefully it did on your end. Let me see if I have something here. Okay, I went ahead and I shaded it. So if you have a note packet that's already filled out, some of you have this, it's not shaded. This one, it's the shaded sector is this part. Okay, so here I have my circle, radius 16. So what I need to do is find out the area of the whole circle, and then I'll find out how much of the circle this sector is, and then I'll divide, or I'll either divide by a whole number or I'll multiply by a fraction to get the area of this part. So the area of the whole circle is going to be pi r squared, so pi times 16 squared. And then the sector in this case is 90 over 360. That's because there's a right angle. So the sector is a fourth of your circle. Well, it's a quarter of the pi. So I'm going to figure out the area here, and then I'm going to multiply that area by a fourth, or I can divide by 4. So this is 256 pi divided by 4 is 64 pi, and we're dealing with centimeters squared. Okay. Let's look at number 10. So here's our circle. We're looking at a smaller sector here. We have a radius 12, and the central angle of the sector is 30 degrees. So let's figure out the area of the circle. That's going to be pi times 12 squared. That's 144 pi. And then our sector is 30 over 360, or what is that? 12? Yeah. So the sector here is 1/12 of the full circle. Imagine a pizza with 12 slices. So if I just want the area of one of those slices, I'm going to divide this answer by 12. Or I can multiply it by 1/12. Same thing. And you get 12 pi inches squared. That's the area of your sector there. Alright, number 12. We have a circle, 45 degrees, a diameter of 16. I'm just going to reconfirm that it's wanting that smaller section. It's not. It's actually wanting the larger section, so it wants everything that's not that little piece. Let's get the area of the circle first. Alright, so this is going to be pi times, I need to divide this by 2 because that's a diameter. So that'll be 8 squared. So that's 64 pi. The sector we don't want, so the sector that I don't want, that's 45 of 360. Let's see if that's a nice number. It is. It's an eighth. So that's an eighth. So the area of this sector that I don't want is going to be 64 divided by 8 pi. However, that's not the answer. The answer is everything that's not that little piece. So I can do 64 pi minus 8 pi. That would be 56 pi centimeters squared. That's going to be your shaded sector. Alright, moving on, let's do number 14. Find the area of sector TOP in circle O using the given information. So first I'll draw a circle O, and looks like TOP, this is T, this is P. TOP is only 15 degrees, and the radius is 6 feet. And we want to find the area of this sector. So first I need the area of my circle. That'd be pi times 6 squared, so 36 pi feet squared. And I need to know how much of the circle is the sector. This would be 15 over 360. 30 over 360 is 1/12. 15 degrees is half of 30, so I just need to half this. So that's 1/24 of the circle. So I just can either multiply this by 1/24 or I can divide it by 24. 12 goes in each of these 3 times and 2 times. So the answer is going to be 3 over 2 pi, don't forget the pi, feet squared. Okay, if you want to put that in a calculator, you'll get 1.5. So that's the same 1.5 pi, don't forget the pi, feet squared. That's going to be your final answer there. Okay, let's look at number 16. So we have a circle. Oops, I'm doing the wrong thing, sorry about that. 16 says D equals 15 centimeters, and the measure of the arc PT is 180 degrees, so it's a semicircle. Okay, so O is in the center, P and T. So we're looking at just half the area of the circle basically. My diameter is 15 centimeters. So all I need to do here is find the area of the circle and divide it by 2, and I'll get the answer. So 15 is my diameter, so I need radius. Radius here is going to be 7.5 squared. I like doing these in fractions because you can easily square each number. This is going to be pi times 225 over 4. And that's going to be centimeters squared. So this is the area of my circle. To get the area of the sector, I just need to half this. So if you divide this by 2, that 4 turns into an 8. So my answer is going to be pi times 225 over 8 centimeters squared. If you're in fractions, or sorry, decimals, 7.5 squared, let's see, what's that? That's going to be there. 7.5 times 7.5 is 56.25, and then divide that by 2. You should get 28.125 times pi. Let's move on to the next one. Ooh, the segments. These are good. Number 18 says, find the area of each shaded segment. Round your answer to the nearest tenth. So here we have a circle, and it's a right angle. Looks like the radius is 8 feet. Okay, so recall how to do these. What I need to do is I first need to find the area of the sector. So that would be this upper right hand chunk of the circle, the whole part, and then I'm going to minus the area of the triangle formed by the segment. That's this part. I don't want that. So when all's told and done, I'm finding this, I'm subtracting the triangle, I'm going to get this little slice on the edge there. So let's look at this area of the sector. To get the area of the sector, I first need the area of my circle. So it would be pi times r squared, so that's 8 squared. So the area of my circle is going to be 64 pi feet squared. And this is a fourth of the circle. Why? Because that's a right angle. So it's 90 over 360. Okay, so the area of my sector is going to be 64 pi divided by 4. Okay, because I'm looking at a fourth of the circle. It'll be 16 pi feet squared. Next, I'll subtract the area of the triangle, which is 1/2 base times height. My base and my height are both 8. So that'll be 8 times 8 times 1/2. Okay, so that is going to be 64 divided by 2, so it's 32 feet squared. My final answer is going to be 16 pi minus 32. I need to multiply 16 by pi. 16 times pi. That's 50.26 minus 32. Minus 32. 18.27 feet squared is the area of your little segment there. Alright, let's move on to number 20. Okay, so it looks like a word problem. A circle has the given radius. Find the area of the smaller segment of the circle determined by an arc with the given measure, round to the nearest tenth. Okay, so what they say is radius is 15 meters, and the arc is 60 degrees, and it says find the area of the smaller segment of the circle determined by an arc with the given measure, round to the nearest tenth. Okay, so we're going to find the area of the smaller segment. So we want, yes, we want this little bit right here. Okay. Okay, so this one's a little tricky. So I'm going to do area of sector, and then I'll subtract that from area of the triangle. Okay, the area of the sector should be easy to get. That's going to be that'd be the area of circle. Area of circle times the portion that this sector is. So this sector is 60 over 360, so it's times a sixth. So the area of my circle here is pi r squared. So 15 times, or pi times 15 squared. So my area of the circle here, the full circle, is 225 pi. Divide that by 6 and you get the area of your sector. What I'm going to do right now is approximate that into decimals. Why? Because we'll be subtracting a whole number. So I need some decimals here. So this is equal to 117.8, and we're looking at meters squared. So that's the area of this little sector right here. Alright, so next part I need to find the area of the triangle. Let's draw the triangle out here. I can see that this is an equilateral triangle with a full base of 15. Okay, so remember that the area of triangle is 1/2 base times height. I need to find the height of this triangle. So what I can do is split this. I'm going to draw an altitude here, straight down. This is now a 30, 60, 90 triangle. Okay, remember that the longer leg is equal to the shorter leg times the square root of 3. Okay, so the shorter leg here is going to be 15 divided by 2. So this is combining a few things. This is a few sections ago. So this little bit here is 7.5. This guy is going to be the shorter leg times the square root of 3. Remember that from special triangles? So this leg will be 7.5 times root 3. And plug that in the calculator. Let's see, square root, how do I do that on this thing? Sorry guys, I'm using my computer calculator. I guess I can just do 3 to the 1/2 power. That works. 12.99, so it's that's about 13. So my height here, we're going back to our little triangle. I have my height, it's 13. That's h. So the area is going to be equal to 1/2 times my base, which is 15, times my height, which is 13. So let's put this all together. 15 times 13 is 195 times 1/2 is going to be close to 100, I think 98.5. So 98.5 is going to be the area of this circle. This is meters squared. Finally, we can find the little area of the segment. 117.8 minus 98.5. And that should give you an answer. Oh boy. Sorry. Why are you doing this? No, clear. Let me clear this thing. I pressed some button and now it doesn't like me. I'm going to reopen it. Guys, avoid computer calculators if you can. 117.8 minus 98.5. The area of the segment is 19.3 meters squared. Alright, and that should cover it for these. Okay. Look at number 19. You'll have to use the same procedure here for getting this height to get the area of that triangle. And it says find the segment that's shaded. Okay, so it's just that little sliver up top there. What you could also do is, for 19, I don't know if you're looking at this, 19 we could figure, we could get a triangle with an angle of 120 degrees, and then just, you could draw a segment for that triangle, and then just take half of your answer. So like, you would use the same procedure for finding out the area of this triangle, and then instead of subtracting that full thing, you subtract it and then divide it by 2 since you're just finding this little sector. I'll tell you what, I'm going to do number 17 right now, just because. Okay, so here's our circle, and this is 120 degrees. So the full circle here is pi r squared, so 36 pi. The segment we're looking at is a third of that, because 120 divided by 360 is a third. So this segment here is 12 pi. Then I need to subtract the area of the triangle to get that. So looking at this triangle here, let's draw this out. This is an isosceles triangle with a central angle of 120. Why is it isosceles? Because the radius is 6, so each of these legs is the same length. This is 30 out here, and this is also 30. Okay, so I'm just going to flip this upside down so we can look at it with a good orientation. Okay, so I've got, this is 120. I split it in 2. These were 30. So now we're looking at a 30, 60, 90 with a hypotenuse of 6 units. We need to find the height. To get that, I first need to find the shorter leg. Oh, I'm sorry. The shorter leg is this leg. It's obviously shorter than this leg. This would be the longer leg. Remember here that the hypotenuse is equal to 2 times the shorter leg. So that makes this really simple. The height here would just be 3. So to get the area of this triangle, 1/2 base times height. Your base, oh, we still need to find this one. So the base, or the longer leg, is going to be equal to the shorter leg times root 3. So this base here will be 3 times root 3. So the area of this triangle will be 1/2 times 3 times root 3 times 3. That comes out to 4.5 times root 3. And let's put that in the calculator. I'm just going to do, I'm going to get the approximation of root 3 to make this easy. It's about 1.73. So 3 times 1.73, oops, not 3. 4.5 times 1.73 is equal to 7.785. So this triangle here is 7.785. Units would be centimeters squared. So then the sector is going to be 12 pi minus the area of the triangle, 7.785. So 12 pi minus 7.785, about 29.9 centimeters squared would be your sector in that case. Okay guys, so this takes knowledge of those special triangles to be able to do. I know some of these may be a little tricky. Try the challenge if you're up for it. Okay? But don't beat yourself over the head for it. I will not knock you down if you do not attempt the challenge problems. Alright, good luck.